Hey, tech enthusiasts. Welcome back to the Prompt AI podcast from Japan. Picture this. You're typing away on your computer and a suggestion pops up, almost reading your mind. Ever wondered about the magic behind it? Today, we're going to dive deep into the world of large language models, specifically focusing on RNNs and CNNs. These might sound like complex terms, but trust me, by the end of this episode, you'll have a grip on them. Let's get started. RNNs, or recurrent neural networks, are like the memory keepers of the AI world. They have the ability to remember previous input, making them perfect for tasks like predicting the next word you're going to type. Imagine having a conversation with a friend, and you remember what was said just moments ago. That's what RNNs do for machines. Now, CNNs, or convolutional neural networks, on the other hand, are the visionaries. They're fantastic at processing visual data, like images. Think of them as the eyes of the AI, filtering and processing the details to recognize patterns. When we combine the capabilities of RNNs and CNNs, we get a potent mix, and they play an indispensable role in shaping large language models like GPT. All right, time to shine a light on a geeky tale. Did you know the origins of CNNs can be traced back to the visual cortex of animals? It's fascinating. Scientists observed the way cats processed visual stimuli, noticing how specific neurons lit up for certain patterns. This revelation became a stepping stone for designing algorithms that mimicked the same pattern recognition prowess. So, in essence, every time you see a social media platform auto-tagging your pictures, you can thank our feline friends and the dedicated scientists observing them. See, it's all connected. Well, my curious listeners, that wraps up today's deep dive into the mystical world of RNNs and CNNs. I hope you're leaving a tad smarter and definitely more enlightened about the AI magic happening right beneath our fingertips. Tomorrow, we have something even more exciting in store for you. Stay curious, and until next time, keep exploring. Hello, tech enthusiasts. Today, we're diving deep into an innovative approach to machine learning, the art of making machines forget. Imagine training a model with a vast amount of data and then selectively making it unlearn certain parts of it. Sounds intriguing, right? Well, that's precisely what we're uncovering today, based on a groundbreaking research paper I came across. The key takeaway: an algorithm called Prompt Certified Machine Unlearning, or PCMU for short, that revolutionizes the way we think about data removal from trained models. Stick around for the juicy details. Machine unlearning isn't just a fancy tech term. It's rooted in the right to be forgotten, a concept where individuals can request their data to be removed from online platforms. But here's the challenge. Conventional methods that combine training and unlearning often come with a hefty computational price tag, especially with massive data sets. This is where PCMU shines. Rather than going through the tedious cycle of training and unlearning repeatedly, PCMU smartly does a one-time operation. The best part? It doesn't even need to know which data you want to remove in advance. But how does it achieve this magic? The researchers made an ingenious connection between something called randomized smoothing, used for ensuring classification robustness, and the unlearning process. Without diving too deep into the math, think of it as a way to add a protective layer around the data, ensuring that when you remove something, the overall structure remains stable. All right, for those who love to geek out, here's a fun tidbit. Randomized smoothing isn't just a tool for machine unlearning. It's widely used in the AI community for enhancing robustness against adversarial attacks. These are crafty inputs designed to deceive neural networks. By using randomized smoothing, AI researchers can shield models against these malicious inputs. And now, with the introduction of PCMU, this technique has found a new application, ensuring our models can efficiently forget data when needed, all while maintaining their robustness. How cool is that? And with that, we wrap up another episode of Prompt AI Podcast from Japan. If you're as excited about the future of AI and machine unlearning as I am, you won't want to miss our next episode, where we'll delve into another tech marvel. Hello, tech enthusiasts. I hope you're all having a fantastic day. Today, we're diving deep into the fascinating world of large language models, particularly focusing on an intriguing aspect: their personality traits. Can a machine truly have a personality? What's the science behind it? We've got some groundbreaking conclusions to discuss, so buckle up. Let's set the stage. The emergence of large language models, or LLMs, has significantly changed the landscape of natural language processing. These models, like GPT, can produce text that's not just coherent, but eerily human-like in its context and relevance. But here's where it gets even more interesting. Recent research, including the one we're discussing today, has delved into whether these models can exhibit specific personality traits. Imagine having an AI chatbot with the enthusiasm of a morning person or the wit of your favorite comedian. The study I'm referencing, titled Personality Traits in Large Language Models, suggests that as these models grow and evolve, they might just be capable of showcasing nuanced behaviors akin to human personalities. The implications? Well, it could mean more relatable AI interactions, tailored AI responses based on user preferences, and so much more. Now, for the geeky bit that I know you've been waiting for. Did you know that the underlying architecture of models like GPT, called transformers, can be thought of as attention mechanisms? They decide what to focus on when processing vast amounts of information. Here's a thought. Could it be that the personality we perceive in an LLM is, in fact, a result of these attention patterns? Just as humans might focus more on certain stimuli based on their personality traits, like an extrovert noticing social cues more than an introvert. Could LLMs be doing something similar, but in the digital realm? Food for thought, right? And that's a wrap for today's episode. If you're as captivated by the world of AI and tech as I am, make sure to tune in daily for more insights and updates. Curious about how AI is revolutionizing industries, from healthcare to entertainment? Well, that's our topic for the next episode. You won't want to miss it. Until then, stay curious and keep exploring. Hey there, tech enthusiasts. Today, we're diving deep into an intriguing topic that's been at the forefront of the AI world. Imagine having an AI model that's trained to follow prompts, and it's doing an amazing job. But here's a twist. What if someone could sneakily add a backdoor to this model? Intriguing, right? Well, recent research titled BadPrompt, Backdoor Attacks on Continuous Prompts, has explored just that. The findings? The AI universe might be more vulnerable than we thought. Let's unpack this together. Prompt-based learning is making waves in the AI community, particularly for its stellar performance in NLP tasks, especially in those tricky few-shot scenarios. But like every shiny piece of tech, there's always a flip side. paper we're discussing today has uncovered a potential security blind spot. The research indicates that there's a possibility of backdoor attacks on these prompt-driven models. Imagine a sneaky code or pattern that, when triggered, makes the AI behave unexpectedly, and perhaps not in a good way. The method, termed BadPrompt, consists of two intriguing modules: the trigger candidate generation and the adaptive trigger optimization. These modules are designed to exploit the vulnerabilities in few-shot scenarios, maximizing the impact of their sneaky backdoor. Now, for those of you itching for a geeky deep dive, here's a nugget for you. The backdoor attacks are formulated as a unique optimization problem. It's like a math puzzle where the attacker tweaks the model's training data, making it behave erratically when it encounters a specific trigger. And the most fascinating part, the attacker only uses clean models to train this backdoor, making it lightweight and efficient. It's a blend of cleverness and mischief, and it highlights the importance of robustness and security in AI. Well, that wraps up today's episode. I hope it left you pondering about the vast world of AI and its endless possibilities, both good and, well, challenging. Stay tuned, because in our next episode, we're exploring another groundbreaking AI innovation. And remember, the tech universe is ever evolving, so join us daily for fresh insights. Until next time, keep the tech flame burning bright. Hello, tech enthusiasts. Welcome back to the Prompt AI podcast from Japan. I'm your host name, and today we're diving deep into a game-changing approach in the world of continual learning. Can you imagine a world where deep neural networks can learn and remember more effectively without the dreaded forgetting? That's what today's topic is all about. And trust me, it's revolutionary. You see, deep neural networks are incredible. They perform astonishingly well in a plethora of machine learning tasks. But there's a hiccup. When they learn multiple tasks in a sequence, they tend to forget previous ones. This phenomenon is termed catastrophic forgetting. But here's where it gets exciting. A recent paper I stumbled upon introduces a paradigm called S-prompting, and it could be the answer we've all been waiting for. The essence of S-prompting is to learn prompts independently across different domains using what? You guessed it, pre-trained transformers. This approach sidesteps the need for exemplars, which are commonly used in traditional methods. The results? A win-win scenario where each domain gets the best treatment without interference from the others. Moreover, this method is incredibly scalable. We're talking about a mere 0.03% parameter increase per domain. And the cherry on top? It outperforms many state-of-the-art methods, showing an average improvement of about 30% in domain incremental learning tasks. All right, for those tech nerds out there, here's a juicy tidbit for you. The concept of prompts in AI isn't new. They've been around and have primarily been associated with language models. But the magic happens when these prompts are coupled with pre-trained transformers, like the ones in our discussion today. This synergy allows the model to focus its attention, much like how we zoom in on essential details when we're reading or watching something. The beauty of it? It's like giving our AI a supercharged brain that knows precisely where to look and what to remember. And that's a wrap for today. I hope you found this as intriguing as I did. Stay tuned for our next episode, where we'll be delving into another groundbreaking AI technology. And remember, we bring you daily updates, so make sure to keep us on your radar. Until next time, keep exploring, keep innovating, and keep listening. Goodbye. Another episode of the Prompt AI podcast from Japan. Today, we're taking a deep dive into a groundbreaking piece of research that brings a revolutionary perspective on generative models and their control. Imagine being able to guide an AI to generate specific visuals based on text, or even correct its biases. Sounds intriguing? Well, that's exactly what the Generative Visual Prompt, or Prompt Gen, does. And by the end of this episode, you'll understand just how it achieves that. Let's get to the heart of it. Generative models are like artists. They learn the nuances and styles of data and produce unique pieces. However, the challenge has always been directing these artists. What if you want a specific scene or characteristic? Previously, this was a tall order. But the researchers at Carnegie Mellon University have introduced a game changer, the Prompt Gen. Here's how it works. The Prompt Gen acts like a director, guiding the generative model, our artist. By incorporating knowledge from other models, it can 1. Use text to guide image generation with the help of the clip model. Imagine typing a serene sunset over a bustling city, and the AI painting just that. 2. Correct biases in the generated images using image classifiers. It's like having an editor who ensures the art is diverse and inclusive. 3. And for those who are into graphics, with inverse graphics models, the Prompt Gen can make the same image strike different poses. Think of a 3D character model, but you get to decide its pose. But that's not all. The research even found a reporting bias in the clip model, which the Prompt Gen can rectify iteratively. It's like having a self-aware artist that corrects its mistakes. Now, for the geeks in the room, here's a juicy bit. The Prompt Gen works by defining control as energy-based models, EBMs, and samples images in a feed-forward manner. It approximates the EBM using invertible neural networks, which means no optimization is needed at inference. It's like having a super efficient production line, where the artist, director, and editor all work seamlessly together without any hiccups. That's a wrap for today's episode on the Generative Visual Prompt. The world of AI never ceases to amaze, right? Stay tuned, because in our next episode, we'll be exploring another AI marvel that's reshaping industries. And remember, for daily updates on the latest in AI, make sure to subscribe and never miss a beat. Hey there, AI enthusiasts. Welcome back to another episode of Prompt AI Podcast from Japan. Today, we're diving deep into the incredible world of large language models, specifically focusing on the art and science of prompt engineering. Here's a fun fact to kick things off. Did you know that the performance of these AI giants significantly hinges on the quality of the prompts fed to them? Our research spotlight today uncovers a breakthrough in this domain, an automatic prompt engineer, or APE for short. Spoiler alert, it's changing the game in how we generate and select instructions for AI. So, what's this buzz about APE? Think of it like an AI that's trained to make other AIs better. Traditionally, prompts have been handcrafted by use, the humans. But APE, inspired by classical program synthesis and human approaches to prompt engineering, automates this process. It treats instructions as a program and optimizes them by searching through a pool of potential instructions. This ensures the AI gets the best possible guidance. And guess what? When tested on 24 diverse NLP tasks, APE-generated instructions didn't just match human-created ones. they outperformed them on a whopping 19 tasks. It's like having a master chef who not only cooks gourmet meals, but also teaches other chefs to do the same. All right, for our tech geeks out there, here's a juicy tidbit. The backbone of AP's success lies in its method of treating instructions as a program. It's all about optimizing. By searching over a vast pool of instruction candidates proposed by an LLM, APE zeroes in on the most effective prompts. It's a bit like searching for a needle in a haystack, but the needle is gold and makes everything better. What's even more fascinating, APE engineered prompts can steer models towards truthfulness and informativeness. Imagine guiding an AI not just to be accurate, but also to be genuinely insightful. It's like tweaking a car's GPS to not just find the quickest route, but the most scenic one. And there you have it, a deep dive into the future of prompt engineering with APE leading the charge. Before we sign off, here's a little teaser for our next episode: the ethics of AI, balancing innovation with responsibility. Make sure you tune in for that intriguing discussion. Remember, we're here with daily updates, keeping you at the forefront of AI trends and innovations. Until next time, keep questioning, keep exploring, and most importantly, keep innovating.